A denary value can be converted into hexadecimal and binary. Complete the table to show the hexadecimal and 8-bit binary values of the given denary values. So we've been given 49, 123, and 200 as denary values. We need to convert them into hexadecimal and into 8-bit binary. The way that we're going to convert our denary numbers into hexadecimal is actually through binary. So we're going to start with converting our denary number into 8-bit binary. We've done this before, so I'm not going to go through the method again. However, I will go through it with you so that you can see how it's done. So starting off with 49, we want to convert 49 into 8-bit binary. They say that we need 8 bits, so we're going to use our method 2 that we've done in the previous video. We're going to start with the number 1. Take this number and multiply it by 2. We're then going to take 2, multiply that by 2, so we get 4. Multiply that by 2 and continue until we have 8 distinct numbers. 16, 32, 64, 128. All right, we now have 8 numbers. You can count those up. And these represent our 8 bits in the binary number. We're going to go left to right, seeing if each number can fit into 49. If it does, then we're going to subtract that number from 49. Starting off with 128. Can 128 fit into 49? The answer is no. So we're going to put a 0 underneath 128. Next number, does 64 fit into 49? The answer is no, so we put a 0. Does 32 fit? Well, it does, so in this case, we're going to write out 49 minus 32. That's going to give us a result of 17. And we're going to place a 1 underneath the 32, since we've used it. We're now looking at 17 as our base value. Does 16 fit into 17? Yes, it does. So we're going to subtract 16 from 17. This is going to result in 1, and we're going to place a 1 underneath 16. Next number, does 8 fit into 1? No, it doesn't, so we put a 0. Does 4 fit into 1? No, it doesn't, so we put another 0. 2 does not fit into 1 either. Let's put a 0. And finally, 1 does fit into 1, so we can subtract it if you really want, but you should be able to see that this is now 0. So we're going to put a 1 there. And this is now our binary number. Let's bring it over. And that's that. Let's convert the next two denary numbers into 8-bit binary. We can do this slightly quicker now. Again, we're going to follow the same process of writing out the numbers from 1 to 128, going from right to left. All right, now going from left to right, does 128 fit in? No, that does not fit in, so we're going to put a 0. 64 does fit into 123, so let's subtract that. This gives us 59, and we're going to place a 1. 32 does fit into 59, so let's subtract that. That gives us 27. We can place a 1 under the 32. 16 does fit into 27, so we subtract that. That gives us 11. We'll place a 1 underneath 16. 8 fits into 11. That'll give us 3. Let's place a 1 underneath the 8. 4 does not fit to 3, so we'll put a 0. 2 and 1 both fit to 3, so we'll place 1s and 1s. Alright, we can do the subtraction if you really want, but this should be clear now. Let's bring our binary number over, and we'll do the last denary number, 200. 128 fits into 200, so let's write that down. 200 minus 128. That's going to give us 72. And we'll write 1 underneath the 128. 64 fits into 72. Let's place a 1 underneath 64. This results in 8. 32 does not fit into 8. Let's put a 0. 16 does not fit into 8. And 8 does fit into 8, so we can subtract that. And we're left with 0. We can then place a 1 underneath there and zeros under the rest of the numbers, as they do not fit into 0. Let's bring the number over. And there is our 8-bit binary column. Let's go ahead and convert our denary number 49 into hexadecimal. We're not going to use the denary number. Instead, we're actually going to use this 8-bit binary number that we worked out. So the method to convert from binary into hexadecimal is very simple. We're going to start on the right-hand side of our binary number, and we're going to count 4 places. So let's count 1, 2, 3, 4, and let's write down this binary number, 0001. All right, so we're going to do the same thing. So let's count 4 more places, 1, 2, 3, 4, and we're going to write down this binary number, 0011. Let's place it over here. The point of counting 4 places is because a single hexadecimal digit is equivalent to 4 binary bits. Any hexadecimal number from 0 all the way up to F can be stored using 4 binary bits. This is also called a nibble. Now to convert this to hexadecimal, interestingly enough, we're going to take each of these 4 bits and convert them into denary. So for this first nibble, the way we're going to convert it is by starting again on the right-hand side with writing down 1. We're going to multiply this number by 2. That's going to give us 2. Multiply that number by 2. That gives us 4. Multiply this number by 2. And that gives us 8. And you can see that this is the first 4 numbers of this conversion method. Now all we do is whenever we have a 0, we're going to cancel out that number. Whenever there is a 1, we're going to circle the number. So let's go through this. 8 gets cancelled, 4 is going to get cancelled out, 2 is going to get cancelled out, and 1 we're going to keep. Then if we add up all the numbers that are circled, in this case only the 1 is circled, we get our result, which is going to be 1. So that is our first hexadecimal number. The second one that we have over here says 0011. Let's do the same method. Start with 1, multiply it by 2, multiply that by 2, and multiply that by 2. Then cancel out when we have a 0, and then circle when we have a 1. So cancel out 8, cancel out 4, circle the 2, and circle the 1. Let's add the circled numbers. That's going to give us 3. So to get the resulting hexadecimal number, make sure that you have these in the right order. So the order of the 8-bit binary number first went 0011, meaning we'll put this 3 first. Then we had 0001, meaning we put this 1. So 31 is our hexadecimal number, which we're going to put over here. Let's do the next one. Next one is 123, and we'll apply the same method. Let's again count 4 places starting from the right-hand side. This is also called the least significant bit. And we'll count 1, 2, 3, 4. Our first number here is 1, 0, 1, 1. The second number, as you should be able to see, is 0, 1, 1, 1. Again, we'll do the same process. And let's go ahead and cancel where we have a 0 and circle when we have a 1. So we're going to circle the 8, cancel out the 4, circle the 2, and circle the 1. Let's add these numbers together. So we're going to get 8 plus 2 plus 1, which gives us 11. 11 is a denary number, so the conversion into hexadecimal is going to be B. Just a quick recap on the hexadecimal numbers. If we count up in denary, we can go 0 up to 9. After 9, to count up in hexadecimal, we're going to say A, each of these numbers is equivalent to the denary numbers 10, 11, 12, 13, 14, and 15. So you can see that in this case, 11 is equivalent to B. The next number, let's apply the same method. There is a 0, so we're going to cancel the 8, and we're going to circle the rest of the numbers. Add them together, so we have 4 plus 2 plus 1. That gives us 7. All right, so making sure we get the right order, the first number was 0, 1, 1, 1. So that's going to be 7 from down here. The second number was 1, 0, 1, 1. So that is going to be B. So 7B is our hexadecimal number. Let's do the last number, which is 200. Again, we'll apply the same process, and you should be able to see now that the first 4 digits is 1000. Let's write those down. And we have 1100. So we can write that down. Applying the same method as we've done before, we're going to cancel where there is a 0 and circle where we have a 1. Circle the 8, cancel 4, cancel 2, cancel 1. So this number is simply just 8. Same thing for this one. 1, 2, 4, 8. We're going to circle the 8, circle the 4, cancel the 2, cancel the 1. Adding these numbers, we get 12. 8 plus 4 is 12. And 12, if we look at our lookup table here, we have C for the hexadecimal digit. So the answer there is C. So the correct order is going to be 1100 first, then 1000, meaning that our answer is C8. And there we go. That is our completed answer.